Hello, Trinity HistoryCon, and welcome to our talk. My name is Chris Hayward. I'm a PhD student in classical archaeology at the University of Cincinnati, although for the purposes of this exercise, my more relevant qualification is that I am the author of the long-running but terminally unsuccessful blog Pokemoniacal, where I talk about design, world building, and storytelling in the Pokemon games and TV show.
Hello, my name is Elena Romero-Passerin, and I'm a PhD student in the history of science at the University of St. Andrews. I work on the history of botanic gardens in the 18th century, and as such, I have done extensive research on the history of natural sciences in the early and late modern era.
We all know Pokemon, right? The game where you catch monsters and raise them and train them to fight for you. You've got to catch them all. Well, the idea that we want to get people thinking about today is that the heroes of Pokemon are doing science, that they always have been, and that Pokemon has ideas about science that are worth examining. Some of them praiseworthy, others that we are a little more ambivalent about. Fundamentally, Pokemon is a game about collecting, about, as Professor Oak says, trying to produce a complete guide on all the Pokemon in the world by going out into the field and capturing them. You can do this by collecting data on all the Pokemon you have ever owned, even temporarily, but a lot of players actually create something called a living Pokédex, a literal collection of every species that exists, including individuals at every stage of each species' life cycle.
Now, I want to make a parallel with the history of botanic gardens, which first appeared in Europe in the midst of the 16th century as collection of medicinal plants to help medical students learn about pharmacy. As the collections of botanic gardens grew well beyond medicinal plants, they started to have this project of recreating the Eden by collecting every single plant of the earth into one garden, creating, therefore, a living collection of the entirety of what they considered to be creation at the time.
In Pokemon, the idea of a complete guide or collection is a realistic project because the number of Pokemon is well defined and finite. It's kind of a fantasy of how a naturalist's collection might be completed in a neater and more orderly universe than the one we actually live in. On the other hand, nature never runs out of new species, and neither do the game designers. Every game adds more new Pokemon, and the complete collection gets more and more daunting over time, to the point that even though we all know gotta catch them all, they actually stopped using it around 2003. They brought it back for a while in 2013, but it's actually not in very much official media anymore.
In the course of the 17th century, as Europeans visited more and more of the globe and encountered more and more new species, it became obvious, even to the most dedicated of the Eden recreator, that this project was never going to be completed. Because it was simply impossible. This phenomenon has been described by historians as the loss of Eden, the realization that there was no hope to collect all of nature and that botanic gardens could only assemble so many plants. It is metaphorically quite similar to what led the Pokemon game designer to abandon their famous slogan. And this is not the only parallel between Pokemon and early modern science, which is the topic of our paper today.
In every game in the series, one of the first things that happens is you meet a professor, a scientist, like this guy, Professor Samuel Oak. The professor usually gives you your first Pokemon, but they also give you a device, the Pokdex, which the games present as a data collection tool. It records information on every Pokemon you catch, physical data like height and weight, what kind of powers the Pokemon has, its habitats and behavior. And this device is the instrument that you are supposed to use to fulfill this grand ambition of an encyclopedia of all Pokemon. Later titles in the series put less emphasis on the Pokédex quest, but the idea that you're involved with some kind of scientific investigation doesn't go away. There is always a professor studying some kind of mystery about the world and its creatures, usually something to do with either the story or a new game mechanic, sometimes both. The games that introduced Pokemon eggs and mechanics for breeding your Pokemon had a professor who was studying Pokemon eggs and made new discoveries based on the protagonist's observations. The mobile game Pokemon Go makes the professor and his assistants even more crucial. You interact with them constantly, and almost all of the game's objectives are explicitly framed as furthering their research projects.
Now, obviously, data collection and then analysis is a common framework and pattern for science in general. In this specific form, however, it is especially reminiscent of the collecting practices of early modern and 19th century science, European science specifically, which will serve as a comparative element here. In the 17th and 18th century, many scholars of nature formed networks around them to help collect species from all around the globe. Scientists who formed some of this network include very famously Carl Linnaeus or Bernard de Jussieu, who had contacts everywhere on the planet to send them back species of animal, minerals, and plants from where they were, to then be processed in Europe by being compared with the rest of the global data. One concrete example would be, of course, the Botanic Garden, in which plants collected from all around the world are brought back and classified once in Europe by being compared with the rest of the plants that are already there. This is the map of the provenance of species found in the Botanic Garden of Edinburgh at the end of the 18th century, and you can see that it does have a global reach. This simple pattern has been theorized by the historian Bruno Latour, who called the European centers the centers of calculation. In his pattern, data comes from all around the world and is processed in Europe to create scientific information. Obviously, this pattern is extremely simplistic and completely lacks nuance and has been highly criticized since. But it is a useful pattern to think about, but also it fits exactly the model used in Pokemon, wherein data can be collected by anyone because the science is not necessarily what happens at the point of collection.
The protagonists of the Pokemon games are not scientists. Not only do they not have any training as scientists, they're literal children. The exact age varies over different titles in the series, but the range is roughly 10 to 16. In the most recent series of the TV show, this goes as far as the protagonists, a pair of 10-year-olds, receiving research fellowships at an independent lab. And yes, I hate them, but that's not the point. The point is that these non-professionals are presented consistently as being essential to the work of scientific progress. And not even just for doing grunt work, they have skills that the scientists do not. Wild Pokemon are dangerous and unpredictable, and young Pokemon trainers can deal with them on their own terms.
This sort of matched what happened in the 17th and 18th century, wherein collectors could initially be anyone. At the start of the 17th century, often you had non-qualified collectors, such as merchants, diplomats, or just travelers, being required by public authorities, actually, to help with scientific research and collect all around the world where they were going different specimens of different reigns. This led to the development of tools to facilitate this collection by non-scientists, such as guides with brief instructions on how to and what to collect, which is often pretty much everything that you encounter, but also how to send things back. So drying plants, boxing mineral, taking samples, what to take notes of, and building all of the contraptions that would help plants and animals survive the trip back to Europe. Here you can see some examples of boxes to conserve plants and seeds, on the travel back.
In Pokemon, of course, we have the master tool, if you like, the Pokédex, which sort of anticipated the way modern scientists have swung back towards equipping non-professionals with tools like iPads or phone apps to crowdsource the work of scientific data collection. And transporting specimens is no problem thanks to Pokeballs, the ubiquitous capsule devices that store captured Pokemon in a compact form.
In the 18th century, there was an increased qualification of collectors because collectors became being a collector became a specific role. There were people who knew how to collect and were familiar as well with the science at hand. Those people could, for example, be gardeners or rich amateurs who would be practicing botany as a hobby. You have here just John Bartram, who was the gardener in the Botanic Garden of Philadelphia, and actually a pretty famous American scientist who did a lot of field collecting for many people in Europe. The need for the communication between the collectors and the scientists, who would be away and speak different languages sometimes, led to the development of certain tools which are not the Pokédex, but help the communication of easy information, such as the Linnaean system of classification based on sexual organs for plants, which made it extremely easy for people to recognize and classify plants immediately in the field before sending them back. There was specific knowledge and skills to be a collector that started to develop.
The Pokemon games, particularly the more recent titles, I would say since 2011, really like to emphasize that Pokemon trainers are not necessarily full-time professionals, even in their own field. A lot of characters set up by the games as role models explicitly have full-time jobs in addition to being skilled trainers. Authority figures in Pokemon X and Y include a photographer, a gardener, a fashion designer, an inventor, a chef, a news anchor, and a film actress. There are a lot of reasons for this. The designers want these characters to be role models for kids playing the games, and I suspect they also want to echo the idealization of amateurism in sport, particularly the modern Olympics. But it also shows that science in Pokemon is the work of a community with diverse skills and interests, not just a select group of professionals.
Which is also, of course, a reflection of the community doing science in the early modern era. And this data collection system, designed to improve knowledge of the natural world, was designed to serve specific visions of science at the time, and is as well in the Pokemon games.
And Pokemon has a vision for the place of science in the world too. The fictional universe of Pokemon is a utopia. It's a near-future setting with extremely advanced technology that is available cheaply or freely to ordinary people, particularly medical technology, which is how we're able to have a game about making our pets fight each other. Pokemon centers offer extremely high-quality medical care pretty much on demand, and not through magic, which is how you would receive healing in a lot of role-playing games set in fantastic worlds, but through science. Humans can even use technology to undo extinction and bring fossilized Pokemon back to life. This is something that might happen in the real world soon, but we're not there yet. But it's not just technology that creates this utopia, it's the relationship between humanity and nature.
The relationship between humanity and nature was also at stake in the world of science of the 18th century. Obviously, this world was very influenced by the philosophy of the Enlightenment, which at its core was fundamentally about progress. The idea of understanding and classifying nature was associated with understanding the order of the world and discovering natural laws, which would then influence the way that social laws should be designed, because the human order had to match the natural order. There were obviously also religious aspects to the study of natural sciences, because from the 16th century onward and before even then, obviously discovering nature was associated with discovering and understanding the world of God's creation, which was also building a way to live in harmony in this creation.
As young Pokemon trainers, the protagonists of the games directly grow more powerful, more able to influence the world around them by learning about Pokemon. And that's true for the character and for the player. A big part of being a good player in Pokemon is just having the encyclopedic knowledge of the hundreds of different species that you might encounter and the range of abilities they can learn. The same knowledge that you develop as part of this grand scientific endeavor. Besides that, all Pokemon media goes out of its way to show off the way its cast of hundreds of species can take part in human society. Almost every game gives the player options to use Pokemon for transport. Pokemon with water-related abilities can be firefighters or lifeguards. Pokemon with great physical strength work in construction. There are Pokemon that can work as medical staff, or predict the weather, or till the earth for farming. Some are even Pokemon that you'd assume would be predators to one another in the wild, but with humans they live in harmony. This world is run by humans who use their understanding of the natural world to make it serve the interests of human society, ultimately for the good of both. The reverse is also possible, and most of Pokemon's villains are people who, in some way, threaten to disrupt the balance of nature.
Having the balance of nature and also using nature was a big motivation for 18th century scientists. A big practical reason for the discovery of nature was that creation was understood to have been made for humans, and therefore humans should have control and exploitation over nature. Sorry. In the 17th and 18th century, there was an increasing emphasis put on the practical uses of science. For natural sciences, this meant finding new and original way to exploit some of the resources that people had found around the world. For example, working on how to use the potatoes to solve famine issues in Europe, or how to work with rhubarb or rubber. This control was also not only present in Europe, because the Europeans used their control of the colonial empire into creating a global impact on nature by exploiting resources in colonies and moving species around from one place in the world to another to increase productivity. This led to many species being introduced in places where they had never been before, like tea being introduced to India to become mass plantations, sheep being introduced in Australia, cabbages in South Africa, or sugar being introduced in the Caribbean, which led, as we all know, to a huge exploitation of those resources and massive profit for the Europeans.
In Pokemon, just as in the scientific landscape of early modern Europe, knowledge is quite literally power. The more you understand nature, the more you can control it and curate it to create a more ordered society or a beautiful botanical garden. And I think that kind of ethos is why Pokemon, surprisingly, doesn't emphasize wild nature or untouched wilderness very much. It's hard to find places in the Pokemon world where there are no humans or no human influence. And when you play Pokemon Go and encounter Pokemon in the real world, you don't find them in the wilderness, you find them in cities, population centers, places with a lot of people. Environmentalism for Pokemon isn't about insulating nature from humanity, it's about harmony between the two.
Now, there is not an exact strict parallel between the philosophy of science in Pokemon and in early modern Europe. This is especially true if you consider that Pokemon designers were obviously inspired by Japanese philosophies and traditions, but they are parallel in that science is seen as a major force for progress, and there is a drive to learn about the world and control it. Now, why is this important and why we're talking about it today? Because in the real world, this era of exploitation and control over nature had real impact in the world, and that is not always reflected in the game. The want to control and exploit nature in early modern Europe and around the globe led to over-exploitation, not necessarily by the scientists themselves, but by the people they worked for, and often enough encouraged by the scientists themselves. There were already issues of over-exploitation of natural resources in Europe, like deforestation to build ships in the 16th century, but with explorations and settlements around the globe, those problems became global and touched ecosystems that were much more fragile than the European one. Tropical islands famously died out of the influence of the Europeans exploiting them, and this made naturalists take notice because it was very, very obvious. For example, the introduction of new animals and hunting for food and ships led to the famous extinction of the dodo on Mauritius in the late 17th century. In Central America and in the Caribbean coast, the introduction of new European cattle like goats and the size of the population of such cattle led to serious soil erosion. There were also issues with rabbits in Australia or with pets being introduced in New Zealand, which actually drove the population of flightless birds that were native to the region down a lot.
Pokemon's creators understand that careless human intervention in nature can present serious problems, although normally Pokemon presents serious environmental issues as problems of the past. There is no climate change threat, for example. No Pokemon has ever been driven extinct by humans, but Farfetch'd, Lapras, Stantler, and Mudbray were all once hunted to the brink of extinction, only for their populations to recover in modern times. There are also two examples I want to share of deliberate human intervention in the ecologies of the Pokemon world, one that turned out well and one that didn't, both from the island region of Alola, which is based on Hawaii. First, Grimer and Muck, toxic pests that feed on and multiply in industrial waste like factory runoff. These Pokemon were introduced to Alola on purpose to eat plastic waste, and not only does it work, they actually evolve and take on new forms that are better adapted to that new diet. So here, humans have deliberately curated the ecosystem of this region in order to solve an environmental problem, apparently successfully. On the other hand, we have Young Goose, a mongoose Pokemon that was introduced to Alola in order to curb the region's population of invasive Rattata. This didn't work at all because the Rattata just adapted to a nocturnal lifestyle to avoid them, which is a reference to the real failure of introduced mongooses to control rats in Hawaii. Where I think Pokemon drops the ball is that real mongooses are an ecological menace in Hawaii because they mostly prey on vulnerable native birds and reptiles. The government of Hawaii is actively trying to exterminate mongooses, but Pokemon can't do that to Young Goose. It can't deal with being that brutal, so they just live in Alola now, and neither the games nor the TV show deal with the consequences, if indeed there are any.
In the case of real-life early modern science, the careful recording and observation of nature did lead scholars to notice the negative impact of, in this case, Europeans exploiting nature. They noticed the disappearance of some species, the exhaustion of the ground, and the mass deforestation happening in many colonies or settlements. They also noticed that this had negative impact on overall ecosystems and even on people living there. Deforestation was linked to floods and droughts, poor health in general. Ground exhaustion was obviously bad for agriculture, and many other side effects. There were some efforts to protect nature, but they were rarely efficient because of many reasons, including the fact that trading companies and settlement often could just move on to the next island and leave the previous one deserted and in poor health. Obviously, Pokemon did not have to deal with those issues because of the utopian setting it is using. Now, the problem is that Pokemon is one of the rare franchises that could address those issues. There are very few franchises in modern pop culture that emphasize the role of natural scientists. You might know some of the famous botanists, biologists, or zoologists that have been in some recent pop culture productions, but their natural sciences skills are not always presented either in the best light or necessarily really valued in the narrative that they play in. Considering the current status of our planet and of science and the way we live today, why is there not more representation for those sciences and those skills that would actually be more useful? Why is the world always saved by engineers instead of being saved by botanists and zoologists? As Nando's versus Movies said in his video about the Fantastic Beasts franchise, we need this representation now more than ever for role models for the next generation to emulate.
Pokemon's spiritual heritage is the work of taxonomists and catalogers, people who once dreamed of the possibility of a complete compendium of all life on Earth. But it's also the work of modern citizen scientists, non-professionals and volunteers who produce the big data that makes our most ambitious research possible, and the work of botanists, zoologists, and climate scientists who organize those projects. And Pokemon, at its best, understands, maybe better than any other global media franchise, how complex and beautiful and mysterious the natural world is, and how vital it is for humans to relate to it from a place of respect and wisdom. Pokemon stories, whether official or fan media, have the potential to be part of the change that this world needs. So, thank you all for joining us, and remember, gotta catch 'em all.